use of interrupt, or what is the necessity of interrupt? Why interrupts are necessary? So here I will give an example. If suppose you are doing your preparations for the examination, okay, and for this examination, when you are studying a particular topic or particular subject, okay, and within the space, if suppose your friend is calling you, okay, on mobile. Now, as soon as the mobile ring, you are receiving the call by stopping your study. Okay. This is the one case. So first case we can say here what happens if mobile rings. Okay. If mobile rings, you can do two things. Okay. Here, first is you will receive call or you will ignore call. Okay, there are these two cases. Okay. Now, when you are receiving the call, what does it mean? Here, you are serving the particular friend, okay, or you are communicating with that particular friend. Now, and when you are ignoring the call, what does it mean? You are not providing any services, okay, or you are not serving the friend. Okay. So here we will write it as not service or not serving the phone. Okay. Now here, whenever the mobile rings and you receive the call, then we can say this friend is having some sort of priority, okay, as compared to study also. Okay. And when you are ignoring the call, what does it mean? You are not thinking that to discuss with the friend for a specific case or for the casual discussion. It is not that much of important as compared to study. Okay, so these are the two cases. Now, here the basic thing is when you are studying here, okay, when you are studying, that is a process that is continuously going on. Okay. And within that process, here your friend is calling you. So here we will write as a friend. Okay, so this friend is calling you. Now, when your friend is calling, that means that particular friend is disturbing you within your study. Now, is it necessary that if the friend is calling you during the study, then to pick up the call or not to pick up the call? Okay, so here whenever the friend is calling, that friend is interrupting you within your study. Okay. Now, in this case, is it necessary to provide such interrupts? What is happening? Hello, am I audible? Okay, so here during the study, this friend is calling you, okay, and that means this particular friend is disturbing you within the study. Okay. So such disturbance in the process, it is called as interrupt. Okay, so it will be called as interrupt. Okay. Now, if this is the case, we will consider in terms of the microcontroller. Then for microcontroller, when the microcontroller is providing any service or doing some sort of functions, let's say this microcontroller is executing some sort of program. Okay, So the program will start here. Okay. And during the execution of program, here if this microcontroller is disturbed by any interrupt, okay, then is it good for microcontroller or not? So here, the first thing which we need to consider is why these interrupts are necessary. So in this, the first thing why the interrupts are necessary is because at the same time microcontroller is serving different what we can say, different processes, okay, or different executions, okay. That means the same microcontroller is communicating with different sensors, let's say 2 or 4 sensors, then actuators and so on. Okay. So this microcontroller is serving for different processors. And within the process, if suppose any sensor or any actuator wants to communicate with the processor, and it is important as compared to the current execution, then in that case the interrupts are necessary. So here these interrupts are provided. Okay. The second thing is when the microcontroller is giving services for different operations, okay, then in that case here the microprocessor needs to keep eye on every input and output. Okay. What does it mean? Let's assume here this is the microcontroller. Let's assume this is a microcontroller. This microcontroller is communicating with different I/O devices. Okay. This is the first I/O device. This is the second I/O device. Let's assume this is the third I/O device, and this is fourth I/O device. Okay. So this microcontroller is communicating with these 4 I/O devices. Okay. Now during the communication, here if suppose the interrupts are not available, then what the microcontroller needs to do? Microcontroller needs to check the status for this I/O device, whether any information or any data is coming from this I/O device or not. Then from this, then from this, and then from this. That means continuously microcontroller needs to keep in loop. That is called as looping structure. So every time microcontroller needs to check the I/O devices. Okay. So that will consume more time. So in spite of that, if suppose microcontroller is consuming or is doing its own operation or executing some program, okay, and during that case, if suppose any one I/O device want to communicate with the microcontroller, then easily he can communicate with the microcontroller by providing the interrupt, okay, or by interrupting the continuous process of microcontroller. So here, what will happen? The time required for the execution of complete program, that will get reduced. Okay, and at the same time, microcontroller did not require to check every I/O device. Okay. That means every process which is done by the microcontroller, if it has provided with the interrupt, then the unnecessary data as well as what we can say, unnecessary time wastage will get avoided or will get removed. Okay. So that's why here the microcontroller requires the interrupts. Okay. So here the second part is here we can call it as, or we can write it as, to avoid the looping. So to avoid the looping, here these interrupts are necessary. Okay. Do you understand it? Why interrupts are necessary? First thing is that where the microcontroller is communicating with the different devices, the first thing is that every time to provide the different processes, the microprocessor does not know to whom the process service is required. So every time the microcontroller needs to check the status of every I/O devices. So in spite of that, here the microcontrollers are using interrupts so that they are getting interrupted, and it will get served, or that particular interrupts will get served. Okay. Now, if you see the interrupt, there are 2 types of interrupts. One type of interrupts are called as vector interrupts, and another type. It is called as non-vectored interrupt. Now, what does it mean? When we are calling vectored interrupts, that means when the interrupts are generated, when these interrupts are generated, at that time, the microcontroller will jump to the specific address location. That means the address of these interrupts, or we can call it as ISR of this vector location, are specified. Okay, or these addresses are predefined. Okay, and in non-vector interrupts, here address is specified by the programmer. Okay, so here address is not provided by the system itself or by microcontroller itself. Okay. Now, again, these interrupts are divided into two more types, okay, in which the first type of interrupts are called as hardware interrupts, and second type it is called as software interrupt. So what does it mean? Here, the interrupts which are generated by the hardware, these are called as hardware interrupt, and when the programmer is specifying some interrupt, then it is called as software interrupt. Now, we will see what actually happens when the interrupts are generated, and then we will move towards these different interrupts types. Okay, so first see, when any interrupt is getting generated, at that time, here whatever the data which the microcontroller needs to serve, or microcontroller is executing some sort of programs, then the microcontroller will first execute the current execution or current instruction. Current instruction will get executed. After execution of this instruction, here the program counter and status register, which we are calling as PSW register, these two data are getting stored on the stack. Okay. And after loading the data into the stack, after that the program counter will get loaded with the new address from the memory, and this new address is the address of ISR of that particular interrupt. Okay. So what is the meaning of ISR? It is called as interrupt subroutine. Okay. So basically it is a subroutine, but this subroutine is designed specifically for interrupt. Okay. So these are some lines which are available for this at that specified location. Okay. And that will get executed by the microcontroller when the interrupts are getting generated. So this program counter and PSW are getting stored on the stack, and then the program counter will get loaded with the new address or the ISR location, and then after that the microcontroller will execute that ISR, and after execution of this ISR, again it will return back to the main program. Okay. And while returning back, what it will do? Again it will, or the program counter program counter will get loaded with the old address which is stored on the stack. Okay. And also the PSW are again getting reloaded. Okay, everyone got it? So here, when the interrupts are generated, first what will happen? First, after the interrupts are generated, here whatever the current instruction is there, that instruction is getting executed by the microcontroller. Okay. Then the next address, okay, or the which is available on the program counter, that will get stored on the stack. Similarly, the PSW is also getting stored on the stack. Okay. After that, the program counter will get loaded with the ISR or interrupt subroutine or interrupt service routine. Okay. So that program counter will get loaded with that address. It will execute that ISR, and again it will return back to the main program, by retrieving the program counter and PSW. Everyone understood it? Now see here, when the microcontroller is when the interrupts are generated and program counter and PSW are both stored on the stack, in that case, the first PSW is getting stored on the stack. After that, next the program counter address will get stored on the stack. Now for storing this data, here basically what happens here, the microcontroller is getting executing the push instruction. Okay, and when the microcontroller is returning from the main program, at that time, whenever the ISR is getting executed, then this ISR is called as return from subroutine. Okay, already we have studied in the instruction set. Whenever there are the interrupts, in that case, to return from or if any subroutine is required for interrupt, then the last instruction of that subroutine is return instruction. But if it is for interrupt, then it is return from interrupt. Now, when it returns to the main program, then first what happens? The PSW, program counter will get loaded with the address, and after that, the PSW will get loaded into the actual PSW. Okay. Now, this process of retrieving the data is called as popping the data. Okay, or it is called as pop. So, while providing the data or storing the data on the stack, here the push process will get executed. When retrieving the data from the stack, the pop process will get executed. Okay, everyone understood it? Hello, I'm waiting for response. So this is the basic process of interrupts. Now, as we have seen, there are two types of interrupt. First, depending upon the address. So first is called as vectored interrupts, and the second type is called as non-vectored interrupts. Now, what does it mean? Here, in the vectored interrupts, here the address location of that specific interrupt is provided, okay, or it is available into the chip. Okay, so it is available into the chip. That's why it is called as vectored interrupt. Okay, so this address is available. Now, what is the meaning that address is available? So when such interrupts are generated, okay, so if suppose the interrupts are generated, then the program counter will get directly by default will get loaded with that specific address. Let's assume 0004 or 008 or 12. Okay, so it depends upon the interrupts. So here, whatever the address which are provided, these are specifically defined into the chip. So when the interrupts are getting generated, directly program counter will get loaded with that specific address. Now, in non-vectored interrupts, here the address is not defined. Okay. So whenever such interrupts are generated, at that time, here we need to provide the location. Okay. So here the location needs to be provided by the programmer. Okay. So the programmer is providing a specific location or specific address, and at that address, the ISR is written by the programmer. Okay. Now here, in vectored interrupts also, when such interrupts are generated and it's having some specific address location, then the programmer can write here the instruction as jump, okay, or short jump or long jump, and can provide the next address location where the program is available. Okay. But here, when it returns from this program, then it is necessary that the program should get returned to that particular specific address location. And from this address location, here the program counter will get loaded with the main program or current execution program. Okay. So this is the difference between vector and non-vector location. Now, similarly, these interrupts are also divided into software interrupt as well as hardware interrupt. Okay. So, here we will write it as software interrupt and hardware interrupts. Now, what does it mean? Now, when we are concerning with the software interrupts, here actually the programmer is designing the interrupt. Okay. So, programmer itself is providing some sort of interrupts, okay, and deciding where the subroutine is available. Okay. So, the programmer will define the interrupts as well as here the programmer provides the subroutine of that interrupt or can write the ISR of this program. Okay. Now, in hardware interrupts, here the interrupts are generated at the external pin of the interrupt, pin of the chip. Okay. So for microcontroller, if suppose the hardware interrupts are available, then these interrupts are generated at a specific hardware pin. Okay. And once the interrupt is getting generated, then the ISR location of such interrupts are also provided. Okay. So we can call hardware interrupts are vectored interrupts also. So these ISR locations are provided, and the programmer writes the program or writes the subroutine to that specific ISR. ISR location. Okay. And then the particular interrupts are getting served. Now, with this software and hardware interrupts, also the interrupts are divided into two more types, in which the first type is called as maskable interrupt and another are non-maskable interrupt. Okay. So what does it mean? See here, I have given you the example of the mobile that rings during the study. Okay. Now, whether to receive the call or not to receive the call, it depends upon the programmer, or we can call it depends upon the you. So here, either you can receive the call or you cannot. You will not. What we can say, you will leave the call. Okay. So here, the necessity of that interrupt or the priority of this interrupt will be decided by the programmer. So it is called as maskable interrupt. So if you want to receive the call, you will receive the call. If you do not want to receive the call, you will not receive the call. Okay. So here the necessity of that interrupt or the priority of that interrupt will be decided by the programmer. Okay. So such type of interrupts are called as maskable interrupts. Okay. Now another type is non-maskable interrupt. Now in non-maskable interrupt, either you are doing any sort of study, and if suppose the mobile rings, you must have to receive the call. Okay. So here, whenever the interrupts are getting generated, then it is having the highest priority. Okay. That means when the interrupts are generated, you have to serve that interrupt. Okay. We will take the same example. Here, if suppose the mobile rang, then you need to receive the call if it is or this call is done by your father. You must have to receive the call. Right. But here it is the call of friend. So it depends upon you whether to receive the call or not receive the call. But here you have to receive the call because here the call is made by father. So here you need either you want to receive the call or not, but you have to receive the call. Okay. So this is the difference between non-maskable and maskable interrupt. So here, if the interrupts are generated, the microcontroller have to have served these interrupts. Okay. Whatever the most important task is done by the microcontroller or is executing some or serving some sort of program, still microcontroller needs to serve this interrupt. Okay. But here what happens, the microcontroller, if suppose is doing some sort of work, then or if suppose from any IO device, if suppose the data is received or if the interrupts are generated, then if microcontroller wish to receive the data, microcontroller will enable the interrupt. If microcontroller do not want to receive the data, it will disable the interrupt. Okay. So enabling or disabling of the data is called as masking of. It's called as masking of interrupts. Okay. So here, if suppose the interrupts are masking type of interrupt, then it's called as maskable interrupt. Okay. And here, the highest priority interrupt, these are called as it is non-maskable interrupt. Okay. So here, for microcontrollers, here there are two types of interrupts also. One is maskable and non-maskable. So we have seen three different ways of interrupts or distribution of interrupts into three different ways, in which the first one is vectored or non-vectored. Then the second is hardware or software interrupts, and the third main difference is maskable or non-maskable interrupt. Okay. So interrupts are divided into these three different types. Okay. Now, up to now, we have seen how the interrupts are generated, how the interrupts are served, and the different types of interrupts which are available into the microcontroller. Okay. Now we'll see the complete interrupts which are available with the microcontroller. So first we have seen the timer interrupts. These timer interrupts are already we have seen into the timer group. Okay, so there are timer 0 interrupt and timer 1 interrupts. So these two interrupts are available with the microcontroller. Then one interrupt which we have seen for during the serial communication. Okay, so this is one interrupt. So these three interrupts are hardware or software. Anyone? Okay, so these are inbuilt interrupts, or we can call it as software interrupts. Okay. The third interrupts, which are hardware interrupts available into the microcontroller, is INT 0 and INT 1 interrupt. Okay. So these two interrupts are generated or are received by the microcontroller at port 3.2 and port 3.3. Okay. So when the interrupts are getting generated at that specific port pin, the microcontroller will receive that interrupt and will serve the specific interrupts. Okay. So these are the total 5 interrupts which are available with the microcontroller. Okay. One more interrupt is also available into the microcontroller. In some cases or in some books, it is considered as interrupt and in some cases it is not considered as interrupt. Okay, so this fourth interrupt type is reset. So it is also called as the interrupt. So when the reset is pressed, at the time what will happen? The microcontroller will get loaded, or the program counter will get loaded with the initial address location 000H, and again the microcontroller will start execution of the program starting from the initial location. Okay, so here also the controller is getting switched from this specific main program to the initial location or vector location. Okay, so it will be, in some cases it will be treated as interrupt, and in some cases it will be treated as only a reset switch. Okay. Now here is, with the timer, two interrupts are available. With the serial, one interrupt is available. These are software interrupts. INT0 and INT1, these are interrupts are generated at the external pin. That's why these are the hardware interrupts. Now, if we see the ISR location, then here for timer interrupt, serial interrupt, as well as for INT0 and INT1 interrupt, for all these interrupts here, the address is specified. Okay. So address is already available. So when such interrupts are getting generated, microcontroller will directly get switched to that particular address location and will serve that location. Okay. That's why these interrupts are called as vectored interrupts. Okay. So for microcontroller, there are 5 interrupts, 2 timer interrupts, 1 serial interrupt, and 2 external interrupts, INT0 and INT1. Okay. After that, the 6th interrupt, it is in some cases it will be treated as interrupt, and in some cases it is not considered as interrupt. Okay. And that is the reset. Okay. So up to now we have seen the interrupt, necessity of interrupt, then the different types of interrupts, what happens when the interrupts are getting generated, and after that we have seen the interrupts which are available with the microcontroller. Okay. Now in the next lecture we will